Hello everyone, this is Group 10 going to present the bypassing Mi-A3 fingerprint sensor using plastic sheet with victim fingerprints on it. So the team members are Malati, Nirosh Kumar and Tushi Sanidhinathan. Okay, so what is a biometrics based authentication system? It seeks to verify the people using feature measures derived by them measuring their physical characteristics. The few examples of biometric systems are the fingerprint, face, retinal, and voice, so on. In the recent year, many personal authentication biometric applications such as fingerprint systems are frequently employed by the smartphone manufacturing companies around the world. Especially, ultra-thin in-display optical fingerprint sensors are the most secure way to capture and identify the human fingerprints in the mobile without an external button. The reason behind that is that human privacy can be accessed in a variety of ways once the lock screen has been removed. This is why new screen lock security measures necessity to be extremely protected. So in this paper, we experimented to bypass the in-display optical fingerprint sensor in the Mi-A3 smartphone. The Mi-A3 smartphone was manufactured by the Xiaomi Mobile Corporation and released in 2019. This Mi-A3 contains a 7th generation based in-display optical fingerprint sensor too. So the optical fingerprint sensor component comes with optical collimator that only 0.26 mm thick. So this sensor enhances the linear motor performance of the smartphone. Moreover, it enables more adaptable and ergonomic solution for the unlocking area. So let's look into the Mi-A3 fingerprint optical sensors workflow. Here are the collected users real-time experience from the well-known technologies review forum about the Mi-A3 fingerprint working. So overall, they says that performance was average and little sluggish in terms of unlock accuracy. So optical fingerprint sensor works based on the certain principle, which includes identify the internal characteristics of the finger surface and subsurface. So observing the optical characteristics of the fingers based on the convexo and convex pattern, as you see here. So the image seen here is OCT format called the optical coherence tomography of the finger. This upper layer of a skin within the finger exists whose optical properties match the surface structure of the fingerprint called convexo-convex patterns, and also these ups called ridges, but this sensor sensing the structure of the subsurface of the upper layer means some upper layer patterns exist inside the tissue of the surface. As you can see here, the layer of this tissue behind that ridge resembles the upper ridge pattern. So let's see the elaboration of in-display optical fingerprint sensor. So once the user places the fingers on the sensor embedded in the display, the LED lights source hit the fingers and finger subsurfaces. In the sensor setup, the red light LEDs rays from the light source illuminate the finger surface placed on the prism or glass cover surface on the mobile. Then the reflection of the light from the finger passes through the employed lens, the concentrate into an image creation device such as CCD or CMOS camera device, also known as solid state image device, so which process the normal image to the brilliant pixel image. And then this is a simplified high level diagram explains the optical fingerprint sensor working model, as I already explained in this diagram here. So how the optical fingerprint sensor algorithm processing for authentication using the image captured from the human fingers. So as you can see, the left side image from the captured using the conventional sensor shows a lot of breaks and cuts in the prism surface of the finger, and right side image captured from the proposed in-display optical fingerprint sensor not having any impacts of moisture due to the LED reflection capturing the interior fingerprint patterns. And also in the second image, the left side image has a lot of cracks and cuts, but the right image is not affected by the wrinkles cut in the finger surface because this image is again captured by the in-display optical fingerprint sensor. These are some of the output examples of this device. So let's see the algorithm matching steps. So first, imaging the captured fingerprint. So the 4 main actions performed on this capturing image, such as checking the figure stability, best exposure control practices, and then perform picture transformation using geometric, and then look for the fake finger. These are the 4 main actions as part of the first step. The second step, the extracting the fingerprint feature for matching. Here, they convert the fingerprint images to the binary image, and the algorithm extract the parallel ridges from this image. So these parallel ridges, also known as minutiae points of the fingerprint pattern, such as ridge edge and the ridge bifurcation. The parallel ridge filters method is used to filter the errorless minutiae points to form the ridge orientations as shown in this image. So final step, to match the input fingerprints with the registered fingerprint data, the two matching methods are followed by this algorithm. The first, rough matching, registered and target fingerprints using orientations of the ridges to match the identical pattern between them. Just by moving the orientations upwards, downwards and right and left direction to check the alignments are same. So after the rough matching, then come to the precise matching. So compare the minutiae data to accomplish the accurate matching as part of this second method. So here the comparing a registered and targeted minutiae patterns by checking the pair's direction, alignment and coordinates. So the matching until it's get perfect identical match. So that's all about this mechanical process. So Maladi will be presenting the ways and experiment results of the hacking fingerprint sensor on the device. Thank you all.
Thank you, Nirosh. So in this slide, we'll be talking about the different ways in which a fingerprint can be hacked. So here we have 3 different ways which are quite inexpensive, and we've used one of the ways in our project. So the first method would be using a 3D printer. So in this, the researchers used a relatively inexpensive, quite cheap 3D printer to make the molds. So it extrudes the UV light that cures the resin. So they tested it out with a number of materials like silicone for casting the dummy prints, and they finally used fabric glue for the mold. To make the fingerprints capacitive, the researchers also designed casts that can be worn as sleeves, so that anyone can wear it on their own finger, which essentially would create a fingerprint disguise. The second method is using the wood glue. So the hackers are able to create a photograph of the fingerprint that's left on the screen. So using this, so they can run it through any image editing software, and they produce almost perfect image, a negative image of the whorls that define our fingerprints. So with this, they can then print the image onto an acetate sheet using a laser printer. So the laser printer uses toner, which is then transferred to the sheet using charged particles. And with this, it nearly leaves an imperceptible 3D structure of the print onto the sheet onto which it is printed. So from here, it's a simple process. The negative image of the print has bumps, which has ridges and valleys in our finger. So by applying a dab of cheap wood glue over this 3D negative, the glue ideally would settle down in the gaps, and it would represent almost a real fingerprint as it should be. Now moving on to the third method, we'll look into it in the next slides. Now in this slide, we'll talk about how the exploit on Mi-A3's in-display optical sensor is carried out. Now this kind of exploit can be carried out only for in-display optical sensors, and it cannot be carried out for the conventional sensor that is found behind the phone. So the first step here would be to carry out capturing the victim's fingerprint on a clear plastic sheet. So in our exploit, we've used a cling film that we use as a food wrap, and we used a food color as an impression of the victim's thumbprint, and this thumbprint was then pressed against the cling film in order to capture it on the plastic sheet. Now the plastic sheet, in our case the cling film, is then placed on top of the display, and it is made sure that the image of the victim's thumbprint entirely covers the sensor so that it is able to read the image properly. Next, the user's fingerprint is pressed onto the fingerprint sensor, and using this pressure, the cling film or the plastic sheet is pressed with the victim's thumb impression underneath. So this should give the impression that a genuine user is trying to unlock the phone. The result of the experiment was not successful, The device Mi-A3's optical in-screen sensor detects the fake fingerprint and does not let it bypass. So we made a few observations on why this exploit did not work. Now, Mi-A3 is one of the few mid-range phones which offers a good in-display fingerprint scanner for a good price. Now, although it was mentioned in the previous sections that optical sensors are comparatively less secure than the ultrasonic ones, the Mi-A3 comes with a 7th generation optical fingerprint sensor. And it has a 3-pixel lens which corresponds to a 7.2 micrometer macro camera. So this is approximately 100% higher than the previous generation's fingerprint technology. And the finger area span is also increased by a factor of 15%, so which means the signal is processed better or captured better. Now, the major reason for the failure of the exploit is that Mi-A3, using its high-end optical sensor, somehow managed to block this exploit. Now, it does feature some of the internal characteristics of the finger. So, optical scanners have several diodes per inch to capture the details of the fingertip up close. So, when a finger is pressed, the area typically becomes dark, and the optical sensors use several LED lights to light up during the scan time. So now, although the internal firmware details of the fingerprint sensor from Xiaomi was not revealed, it can be evident that Mi-A3 uses a good cutting-edge technology for its optical sensor. Now, in this case, the sensor detects the image of the fingerprint. It also detects the ridges in our fingers, which create light and dark areas. The optical sensor does not scan the ridges by themselves, but it relies on this lighting that was created by the contours in our finger. So the methodology used by us in this to detect, to penetrate the system by faking the fingerprint was probably weak. And one of the main advantages of optical scanners is that they are cheap and easy to develop and use. And probably using a high resolution picture might have tricked the scanner in our case. So in this slide, we'll talk about some of the upsides and downsides of optical sensors. So for the upside, we know that they are extremely cost effective, and they're one of the earliest and most commonly used methods, and they are readily available for all the mid-range mobile phones. They're reliable, fast, robust, and there's very great progress in upgrading, and there's a lot of good future work being done in this area. And some of the drawbacks are that they're quite easy to spoof because they make use only of the 2D fingerprint image. And second one is that they're not quite adaptable to environmental factors like temperature, and due to this aging, the image quality could be reduced.
Thank you, Maladi. Protecting the mobile system using a fingerprint sensor in the future point of view. So the future points of view in the fingerprint sensor advancements must include a more sensitive and a high resolution model that can sense liveness in the addition to the other fingerprint with the ridges and valleys. Because the development of electronic device need the fingerprint sensors that are adaptable, steady, and less substitutable to the environment, outwards appearance is also important. So in the future, so protecting the mobile system using a fingerprint sensor as a primary biometrics for the user authentication, it could be improvised by adapting the advanced feature extraction techniques in fingerprint sensors for validation and verifications. So the proposed method is precisely identify the fake fingerprints through an optical sensors called gray level co-occurrence matrix, alias GLCM, introduced by Safira and Rasha and then Fajar, aimed to detect the duplicate fingerprints from images. With the very great perceptions and the examinations of the impact of normalizations on the optical sensors from the various fingerprint pictures. So the GLCM techniques use a different variation of angles such as 0, 90, 45 and 135-degree angles to extract the orientation from the finger ridges of every pixels in the fingerprint images and increasing the accuracy of capturing the patterns up to 85% of the experiment result. So, suggestion from the World Threat Intelligence teams, that's Cisco Talos. So the fingerprint hacking would not be a targeting for a common people like you and me. It's always a target for a well-funded and a famous person who should not use any fingerprint sensors as their primary mode of authentication for anything that they used day-to-day life. So reaching a high success result by faking a current fingerprint system is always the tedious and painful experiments is because of the various real-time obstacles, because the limitations on the material volume and also its properties. Always a demo device need to be verified, verify the functionality of it. Although your fingerprint is unique to you, it still be easily abused. So should be obvious at this point. So you always use the multi-factor authentication system and keep that in the display fingerprint as one of the second or a authenticator in a mobile handset. So for regular users, fingerprint authentication has obvious advantage and offer a very initiative security layer. However, if the user is potential target for funded attackers or their device contains sensitive information, Talos recommended relying more on a stronger password token two-factor authentications so that it need to be added on their day-to-day daily mm, authentication method. So these are the references that we used in this presentation and also in our writing. And thank you, class, and we are open for any questions.